Namaskar. Welcome to the first lecture of control system theory. In this lecture, we are going to start our first chapter, that is Introduction to Control Problem. I am Hiren Kherala from Gyan Manjari Institute of Technology, Bhavnagar. Currently, I am working as assistant professor in electrical engineering department. So, in today's lecture, we are going to deal with some of the introductory part of control system, that is, what do you mean by control system? The second thing is the basic terminologies regarding control system engineering, and what do you mean by open loop control system and what do you mean by closed loop control system. The detailed analysis of open loop control system and closed loop control system we are going to understand in next lecture. Okay, so let's get started. What is control system? So one of the most commonly asked question by control system is, what is the control system? And to answer the question, we can cite that in our daily life there are numerous objectives that needs to be accomplished. And for instance, let's say if we talk about domestic domain, we need to regulate the temperature and humidity of homes or the buildings of comfortable living. As far as transportation is concerned, we need to control the automobile and airplane to go from one point to another accurately, as well as safety point of view too. As far as industrial operation is concerned, the manufacturing process contains the numerous objectives for the product that will satisfy the precision and cost effectiveness of requirement. So as a human being, it is capable of performing a wide range of tasks, including as far as the decision making is concerned. Some of these tasks are such as picking up an object from one location and to put at some another location, and this kind of task carried out in a routine fashion. So under certain conditions, some of these tasks are to be performed in a best possible way. For instance, let's say an athlete is running a 100-meter dash, has the objective of running that distance in a shortest possible time. Now the same runner is going for a marathon. Now this time, not only he is focused on run the distance as quickly as possible, but in doing so he or she must control the consumption of energy, as well as to devise the best strategy for the race. Now it means that achieving these objectives usually involve the use of control system and that implement the certain control strategy. So objective is a very important term while discussing the control system. Now as far as recent year is concerned, the control system have assumed an increasingly important role in the development and advancement of modern civilization or modern technology. Practically we can say that every aspect of our day-to-day activities is affected by some type of control system. So let us discuss basic terminology which needs to be understood before going to deal with the examples of control system. Okay, so let us discuss one by one terminology and try to understand what does it mean. First one is control variable. So the controlled variable, the definition says that it is the quantity or condition that is measured as well as controlled, and the manipulated variable is different thing. But what is controlled variable? So normally we can say it is the output of the system. Now let us take an example to understand what is controlled variable. But before that, let me clarify another term, that is manipulated variable. So manipulated variable is nothing but it is a quantity or condition that is varied by a controller so as to affect the value of controlled variable. So both these terms, controlled variable and manipulated variable, are correlated. That is why try to understand both these terms at the same time. Now take an example of a car which is driving by a man, and he is going from one location to another location, and he is having something in mind that he want to run this car at 80 kilometers per hour. Okay, this is fixed. The speed needs to be constant. So now let me just again try to read this definition. So control variable, it is the quantity or condition that is measured or controlled. Okay, so it is the quantity that actually can be measured and controlled too. So as far as our example is concerned, we can measure our speed, and that should be 80 km per hour. It also should be controlled. So speed also can be controlled. That is why we can say that as far as our example is concerned, your controlled variable is nothing but your speed. Now what is manipulated variable? So it is the quantity or condition that is varied by some controller so as to affect the value of controlled variable. So already we have defined that our speed is our controlled variable. So how we can vary the speed? So by adjusting your accelerator or your brake, you can control the speed of the motor. So that is what the manipulated variable is. It is the quantity or condition that is varied by some controller so as to affect our final output, that is our speed. So manipulated variable is nothing but, for our example, it is your either brake or your accelerator is generally known as a manipulated variable. So by using this example, you can clearly understand what is controlled variable and what is manipulated variable. Okay, so for this example, your speed or your output of the system is nothing but your controlled variable, and your brake and accelerator is your manipulated variable, because by changing the value, by changing the acceleration or by applying the brake, you can ultimately change the value of speed, and our goal is to maintain speed 80 km per hour. So sometimes it is happening that there is very traffic in a road. In that case, you have to control the speed of the motor, and by the using brake and accelerator, you can control the speed. So that will be your manipulated variable, and speed will be your controlled variable. So I think both this definition is clear. So next definition, that is plant. So what is plant? A plant may be a piece of equipment just to set of machines part functioning together, and the purpose of which is to perform a particular operation. Now as far as in this subject we will consider, we shall call any physical object to be controlled, such as either it is a mechanical device or a heating furnace or a chemical reactor or spacecraft. Okay, so this kind of system we may call plant. The next definition is a process. It is self-explanatory. What is a process? So process is nothing but a natural, progressively continuing operation that consists of series controlled action directed towards particular result. So whatever you are dealing with, some objective, if you have some objective to achieve, let's say we are making a plastic bottle. So in industries, a progressively continuing operation, so the direction of operation is also the progressive. This word is very important, the progressively continuing operation, that consists of the series of controlled action. So after first we have to just mold into the bottle form, then we have to mold the cap, also we have to make some of the spaces where our cap can be that put aside. So that is why we can say that process is progressively continuing operation, okay, directed towards the particular result. The next term that we are going to understand is system. Okay, just ignore this figure right now. I'll come to this point. What is system? So as far we are discussing about control system, so first thing we have to understand what is system. So system is nothing but a combination of components that acts together and perform a certain objective. Now system is not limited to a physical system. The concept of the system can be applied to abstract or the dynamic phenomena such as those kind of economics encountered in our life. The word system should therefore be interpreted to imply physical, biological, economical, and very unlike system. Okay, the system is a very vast word. Okay, we cannot particularly say our body is also one kind of system. Okay, so we'll come to this word system again when we are dealing with control system, or open loop control system and closed loop control system. But in short, we have to just right now understand the system is nothing but a combination of components that acts together to perform a certain objective. Okay, next is disturbance. So a disturbance is a signal that tends to adversely affect the value of the output of the system. So let's say consider this system where we are giving some input, that controller is going to control by this input signal, that will give you some actuating signal, and that will again fed to some plant, and after processing we are getting some output. Now sometimes it is happening that due to disturbance we cannot get the objective that we are supposed to get. Okay, let us take the same example of I am driving a car at 80 km per hour. So our objective is to drive a car at this constant speed. That is our objective. But what is the disturbance in that case? So disturbance will be the traffic, the bump in a road. Sometimes many peoples can be around the street, so we cannot about to maintain 80 km per hour speed. Okay, so traffic is one of the disturbance in case of our example. So in case of any system, in case of any process or plant, there are many disturbance will be there. Okay, so we have to understand what is disturbance. In that case we can able to deal whenever we deal with a feedback control system. This term will be very important, disturbance. Okay, right now just understand that is the signal that tends to adversely affect the value of the output of the system. Now the next is feedback control system or the feedback control. Generally it refers to an operation that in the presence of the disturbance it tends to reduce the difference between the output of the system and some reference input, and does so on the basis of this difference. So here only the unpredictable disturbance are so specified, since the predictable or the known disturbance can always be compensated within the system. So whenever some undefined or unpredictable disturbance will be there, we have to deal with such kind of disturbance. So feedback control is nothing but we can say it is the closed loop control system. So again and again we are taking some output of the signal, output of the system, and take or compare with every time with a reference input, and it will generate some error into the system, and that error can be minimized using feedback control system or closed loop control system. Okay, this is the basic diagram of open loop control system. Here you cannot see that output of the system is again fed to input, and by comparing we are generating error signal, and that is again going to fed to controller. So this is example of open loop control system. Okay, now let us discuss some of the examples of control system and clarify the picture and the definition that we have already discussed right here. So the first example is of a temperature control system. So here you can see the temperature control system and different equipments are there. Here it is the temperature controller, it is the controller, here is the controlled object where we are measuring. Okay, here it is, you can see the temperature sensor is there, and the function of each and everything is also mentioned in the figure. We are not going to just read out every these things, but let me just clarify what is all about and how the temperature control system generally works. So this is the schematic diagram of temperature control system of an electric furnace. Now the temperature in the electric furnace is generally measured by this thermometer, and this thermometer is generally analog device. Okay, so the analog temperature is converted to a digital temperature by using A to D converter, that is analog to digital converter. Okay, so somehow from this and this will record the temperature in analog form that will going to be converted into digital form by using A to D converter. Now the digital temperature is fed to a controller through interface, and this digital temperature is compared with a programmed input temperature. And if there is a difference between the programmed temperature and the actual temperature, it will generate some error, and then the controller will send out signal to heater. Okay, and it will change some value of the temperature. Okay, so through interface it will going to send some signal to heater, and that will amplify and using relay to bring the furnace temperature to the desired value. So again the desired temperature can be achieved using this thermometer. Again we are going to check the whether our programmed temperature and actual temperature is at the same level or not. If it is not same level, again the controller will generate some signal and it will feed to the electric furnace or heater. It will going to change the temperature. Okay, so this is a closed loop control system of temperature control. Okay, this can with using this we can control the temperature of the system. Let us take another example of water closet tank filling system. This is the simplest example that you can easily understand. So here you can see that it shows the schematic diagram which illustrates the principle of an ordinary water closet tank filling system. Here you can see the ball that floats on the water, and as the ball gets closer to the top of the container in the upper direction, the stopper right here decrease the flow of the water. So as this ball is going upward direction, your stopper is going to come into the downward direction, and that is why the flow of water can be controlled. Now at some instant when your container become full, the stopper shut off, and in that case the water inlet into the system can be 0. So this is the simplest example of water closet tank filling system. So in this way you can understand the concept of closed loop control system. Okay, so here your input is your water and output is your level of water into the container. Okay, now as far as classification of control system is concerned, system may be defined as the link between the output quantity and input quantity. So this is the another example or another definition of system. So what is system? So it may be defined as the link between output quantity and input quantity. So when the number of elements of components are connected in a sequence to perform a specific function, and the group of this form is called a system. That what we have discussed in previous definition. The same way it is also can be defined that the system is a link between your output quantity and input quantity. So as far as a big system may consist of a small subsystem, so we can say, let us for an example, this universe itself a big system, and generally it consists of infinite number of small system. So same way system can be classified according to their function performed, and typically it is going to classify in 3 parts. The first is energy conversion system, the second one is circulatory system, and the third is control system. Okay, here we are talking about linear control system or classical control system only. There is also modern control system. So there is a difference between classical control system and modern control system. One we are right now learning is a classical control system. Okay, So what is energy conversion system? So it is self-explanatory that a system that is used to convert one form of energy to another form is called energy conversion system. So what are the example of energy conversion system? So an electrical generator converts a mechanical energy to electrical energy. So that is one example, because we can say that the another example is electrical motor. What does it do? It will convert your electrical energy into mechanical energy. The second example, second thing is circulatory system. What is circulatory system? So a system which is used to circulate quantity is generally called circulatory system. And which are the example of circulatory system? The first one is the bird circulatory system or air circulatory system in a room. Okay, so this definition is easily understandable, that is why we are not giving more time to this. Third one is control system. So a system which is used to control the output quantity, that is called control system. So example of control system, first one that we have discussed, that is temperature control system, water closet of any container, okay, voltage control of any generator or motor. So that are the example of a control system. Now if output varies linearly with the input and the principle of superposition is applicable throughout the operating range of the system, then the system is called linear control system. Okay, here your output and input vary linearly with each other. So if you are changing your input, your output will going to change linearly. That is what the linear control system. Thus the control system is that means by which any quantity of interest, or we can say the output in a machine or mechanism or equipment, is maintained in accordance with a desired manner. So our main thing is to achieve our objective. Okay, now the output quantity is generally called the controlled variable and input quantity is generally called our command signal or manipulated variable. So this thing is already we have done with one example of car. Now again consider one example of a DC generator that is driven by a prime mover. Now what does DC generator do? It will convert mechanical energy into electrical energy. So it is an energy conversion system. Now the output voltage is a control quantity, and for constant value of prime mover speed, the output voltage depends on the field excitation. Now any change in field excitation will cause a linear change in the output of the system. So a field current is called the command signal. Such a system is performing the dual function of energy control as well as doing voltage control too. Okay, so most of the system we are going to deal with will be dual control system. So energy conversion also will be there, the voltage control also will be there sometime, and it will be some control system with having some linear characteristics. Okay, now the major part of this chapter we are going to deal with the control system that are classified in open loop control system and closed loop control system. Okay, now consider one example and try to understand what is open loop control system and closed loop control system. Consider another example of temperature control. Now you are going to control the room temperature right here. So control of room temperature is generally achieved by switching on and switching off a power supply. Okay, now the power supply to an appliance is switched on when the room temperature is felt low and switch off when the desired temperature is achieved. Now above system can be modified if the duration of application of power is predetermined, okay, to achieve some desired room temperature within the desired limit. A further refinement can be made by measuring the difference between one temperature, that is the room temperature we want to achieve, and the desired room temperature and the actual room temperature. So that is basically the difference between that will generate some error. Okay, so what the disturbance or error is, it will give some value of deflection of what is the actual room temperature and what is the desired room temperature, and it can be achieved, or error is used to control the element, which in turn control the output, that is our room temperature. Now same discussion can be deal with a closed loop control system. So what is closed loop control system? So our output, that is our room temperature, has no control on input. So the control action is purely based on our pre-described calibration only. So a control system can be classified as open loop control system and closed loop control system, and the basic difference between these two types of system is the presence of feedback element in closed loop control system. Okay, so there is no feedback available in open loop control system, but the feedback is available in case of a closed loop control system. Okay, let me write down. So there is feedback is no available, so there is no feedback, and presence of feedback. Okay, so this is what open loop control system and closed loop control system. So this is all about today's lecture. In next lecture we are going to deeply understand what is open loop control system and what is closed loop control system, with example and with advantages and disadvantages of open loop control system and closed loop control system, and we are going to take the difference of what is open loop and closed loop control system, and that then we will conclude this introductory part of the control system. So thank you so much. See you in next video. Thank you.